Hello, this video is the revision for test 3 for 5Parle. It covers symmetry, so axis of symmetry, central symmetry, center of symmetry, and properties of symmetry. It needs to be viewed along with the videos and the worksheets and the textbook questions that are shared on Google Classroom. If you just use this video, it will not be enough revision for the upcoming test. So you need to be able to understand the descriptive properties of symmetry. So I've given you the French descriptions here with brief English descriptions. You can use either in the test. We can see here that central symmetry will preserve lengths when we have two lines here that are reflected through point O here. We have segment CD and segment C prime D prime, and you can see here that all the distances, all the lengths that are shown on here are all the same. So for example, if you go from C to I, that is the same as C prime to I prime. D to I is the same as D prime to I prime, and even the distances from the center of symmetry as well. So I to O is the same as O to I prime, and so on. So the central symmetry will always preserve the lengths. The next one here, we have central symmetry transforms a line into a parallel line. So we have the line here D, it goes through the 2 points EF. To construct this, you will have to reflect point F through point O to become F prime, and E through O to become E prime, and then you can draw your line there, and you can see these two lines are both parallel. Distances again from center O are identical for each respective point. Next one here, we have two identities here. We have the central symmetry preserves angle measurements, and if two figures are symmetrical about a point, then they have the same area and perimeter. So if we look at our two shapes here, we have A, B, C, D, and A prime, B prime, C prime, D prime reflected through point O. All the measurements, all the lengths obviously are going to be the same, but the corresponding angles are also the same. So if we look at angle B here, so that is angle A, B, D. If it corresponds to A prime, B prime, D prime, and this angle will both be identical. Also identical are the two areas of these two shapes, and also the perimeters, the distances around the outside, will also be the same. Now we move on to circles. So if two circles are symmetrical about a point, then they have the same radius. So here we have circle A is where you would have started, and you're reflecting through point O. So we measure the distance there, we double the distance to the other side. So AO is the same as OA, and when we draw or construct our circle here, A dashed or A prime, this circle here will have exactly the same radius as our first one. Those constructions that you've just seen, you will need to be able to perform, and the best way of revising those is to look at the French videos that are shared on Classroom. Here's a quick review again of the 5 statements that you may have to use. Again, you can write them in French, or you can write them in English for the test. You will not be marked down for either. And then looking at center of symmetry, remember I put a note here that the center of symmetry does not equal central symmetry. I say in English it translates a bit strange, but basically the center of symmetry here, these first two shapes have a center of symmetry and the triangle does not. So a center of symmetry is a point whereby if you reflect through, you will get the same shape. So if we see here, B reflecting through O will go to point E, E through O will go to point B. C through O becomes F, F through O becomes C, and A through O becomes D, and D through O becomes A. So O is definitely the center of symmetry here. The same would happen for a rectangle here. A through O is C, and B through O is D, and vice versa. But with the triangle, yes, there's a center to the triangle. You can see it here, but that's not the center of symmetry. What you have here, you have these 3 lines, and these 3 lines are axes of symmetry for the shape, but where they meet is not a center of symmetry. So now onto a couple of questions. Hopefully you looked at the PDF and had a go at these. The first questions here ask if if these figures have axial symmetry, central symmetry, neither, or both. So let's look at the first one. And the first one here, you can see that this image here is kind of reflected onto this one here. But is it through a line? Is it through a point? Well, in fact, this one is through a point, and the point is going to be somewhere around about there. Okay, so we can actually see that this point comes to here, this point goes to there, this goes to here, and this one goes to here. We could even show it by joining up the corresponding corners. Let me just do that in blue. So I can show that, oh, that one will join up there, that one will join up there. And each of these, see, they go through the axis of symmetry like that. So looking at the next one, what we have here is a line of symmetry going through. So let me mark that on in red. So this is axial symmetry here rather than central symmetry. And you can see, hopefully, that this point reflects to here, this one comes down here, and so on and so on. C has no symmetry at all, cannot have symmetry, and your reason would be that the shapes do not have the same area. They are not the same size. So they don't have the same area, don't have the same perimeter. That has no axial, no central symmetry. The final one here, let's have a look. It looks like this point goes to here and this point goes to here. So it looks like we have a axial symmetry of probably around about here. We can probably show that by joining up a couple of corresponding points just by freehand. So it looks something like this. That's pretty poor, but you get the idea. But there's no line of symmetry. So none of these actually have both. In the test, you will probably get an example of axial symmetry, central symmetry, shape with neither, and look out in case there's a shape with both. Okay, here we're asked to just mark the center of symmetry. Remember, that's not the same as the axial symmetry, so it's the center of symmetry. And the first one is fairly straightforward. The rectangle is, the square is here in the middle. And we go along to the next one here, the rhombus, it is going to be here. Now, the next one here, we have a parallelogram, and you can see, does it have a center of symmetry here? Let's have a look. This point would come down here, yep, and then this would go down here. Yep, so yep, that has a center of symmetry there. And then the triangle, as we already know, does not have any at all. So we would just leave that blank and say it does not have any. Next, we have a complete the following sentences question. And we have various different reflections happening. So let's have a look. The first one, it says U. U is symmetrical to A in the axis, and we want to name the axes. Let's have a look at the axes first on my diagram. We have D is one axis coming down here. Then we have D1 is this axis going here. D2 axis going here, and D3 axis going here. So it's talking about those four axes, one of which is going to be the correct one. U is up here, A is here, and as you can see, A clearly reflects through axis number D, axis D. So we can put D in there, and that's the first one complete. Second one, it says C is symmetrical to W through a point. Okay, so where is C? C is down here, W is up here, and if we reflect through, the only point it's going to be reflected through here to get to W is O, so that is through point O. The next one here, F is symmetrical to something in axis D2. F is over here, D2 is here, so F reflects through axis D2 to get us to G. So G would be here. F is an interesting one because if you look at here, F reflects to, let's have a look, F reflects to V in the axis D. F reflects to L through the point O. So F is all over the place. So make sure you get the right reflection for the statement that you're given. Final one here, we have V is symmetrical to G. So V to G. And if you look at it, to go from V to G, that's got to be, it's on the other side of D. In fact, it's on the other side of D2. But to get to there, you are reflecting through point O. So we would need to complete the sentence. V is symmetrical to G through point O, like that. Final one here, we have reflect each shape through point S. So if you're doing a reflection on a grid, I think these are fairly straightforward. What we do, and I'm going to use green for my constructions here. If I go for the corner on my triangle here on the left, it's one diagonal. So let's go one diagonal in the same direction and put a cross. Always a cross, not a point, because when we do our final drawing, we can still see where those points were. Let's go for the bottom corner here. Now this one here, I'm going to trace it a little bit differently. I'm going to say, okay, what have I done? I've gone, let's get to the right color. I'm going to go 3 to the right and 1 up. So I'm going to go 1 up and then 3 to the right. So that bottom corner actually comes up here. Now you can see it with a ruler. If I put a ruler on here, you can see that the line goes through. It's not a very steady hand, but you get the idea that it goes like that. Okay, so let's get rid of that and get rid of our ruler. Okay, and then the final point is the top one here, and I'm going to go 1, 2, 3 to the right and 2 down. So I'm going to go 2 down, 3 to the right. My point is going to go here, and when I draw it, and you'll do it neatly using a ruler, you will get the correct reflection. Okay, now for B is slightly more tricky because the center is in the axis of symmetry. Sorry, the central symmetry is inside the shape, but it still works in the same way. Take each corner and go through it. So let's go here. We've got this first one here, and I'm going to go 1 down, 2 across. So I'm going to go 2 across and 1 down. So that corner goes to here. Then let's go to the corner at the bottom. This one here, I'm going to go 2 across and 3 up. So I'm going to go 3 up and 2 across. So that one goes here. And then the final one, I'm going to go 2 down, 3 across, 2 down, 3 across, and it comes here. And then join them up. I'll do them in red this time. And then these join up to make that shape there. It looks a mess because it's on top of it, but you get to see it. You can leave your constructions on there, but make sure you draw in bold the actual final image. The final thing I cannot recommend highly enough is the videos that we looked at in class. They are all shared on Google Classroom, and if you look at it, there are quite a few exercises that are shared here, so you can actually have a look at the exercise and then try and do the construction. Okay, that's the best way I think of actually trying to revise these ones. So hopefully that video is of use, and hopefully you'll do a whole bunch of revision and you will do very well in the upcoming test. Good luck.